What we're going to do today is the Emerson test, which is a test for slaking and dispersion. That's these pictures here. I'll explain that in a bit more detail. We're going to look at infiltration. We've got a brand new infiltrometer that just arrived yesterday, so we haven't used it. It's the first time we'll be using that machine to monitor how long it takes for water to infiltrate into the soil. And then we're going to do some visual inspection, soil texturing by hand. That's this process here. We'll see what we can learn just by squeezing the soil in our hands when it's got the right level of moisture in it. So those are the three things that we're going to do. The reason that we're going to do the Emerson test to look at slaking and dispersion is because it's a great measure to look at the stability of soil. Dispersion is the process by which soil molecules, solid parts of soil, clay, disperse or stop sticking to each other when they're wet. And those clay particles have, when there's a lot of sodium in the soil, they have a charge on them, like a magnetic charge, which repels them. So we can see here, this is on a farm north of Marulan. Really amazing erosion there. All this sodic subsoil, lots of sodium in this clay here. When it gets wet, it just falls apart. So the topsoil, the thin layer of white topsoil, I mean, it's not that thin, it's probably about 2 or 3 inches there. Once that topsoil's gone, it's what's protecting the subsoil from erosion, and it just falls away. Now, this property was badly managed for a large number of decades, and because it has this fragile sodic soil, once erosion starts, it can do this type of thing. So when we do the Emerson test, we put a small piece of soil in some water. It's best to use deionized water or DI water, but you can use rainwater. That's what I've brought along today, rainwater. The chlorine in municipal water supplies tends to affect the results, but if that's all you've got, you can still have a go with the chlorinated water, and what we're looking to see is just how milky does the water become. How quickly do the little clay particles dissolve and become part of the soil, or do they stick together? So that's the Emerson test, and this is another picture here, same property, same weekend, and you can see we've actually got tree planting going on here. This property, they've decided to fence out the massive erosion gully. You can see it's tens of metres wide and probably about 10 metres deep in some places. So that was part of Sydney University land care. We were replanting in here. But the point really is we've got another picture of dispersion. So this is severe dispersion. The soil has totally collapsed and dispersed almost wholly throughout the water, whereas here it's only slight, none. So that's dispersion, soil dispersing in the Emerson test. The other thing that we'll be looking at is the texture of the soil. What does the soil feel like in our hands? How much of the soil is little tiny clay particles? How much of it is silt? And how much of it is sand? Basically, 3 particle sizes. Sometimes you might find gravel or stones in soil as well, but the main way that soil scientists classify particle sizes in soil is sand, silt and clay, and that's what makes up the texture triangle. It basically says, do we have a lot of sand? We have a sand here, or a loamy sand. If we have a lot of silt, we've got not much clay and not much sand, so we'll have a silt or a silty loam. Like most things in nature, the ideal point is normally in the middle, a clay loam or a loam. But essentially the triangle says lots of clay, a little bit less clay as we come down. Here in the middle we've got medium amounts. Over this side it's mostly sand, not much silt. We might find in the landscape that silt will be on a floodplain, on a river flat, and that sand will be either blown in by wind or moved by water processes. Excuse me? Yes? What's a loam? What's a loam? So it's It's a description for a type of soil.
Yeah.
Yep.
Some have loam after them, so what's the difference between clay and clay loam?
Right, so you can see here the loam doesn't have as much clay in it. So if it's got lots of clay, if it's 100% clay, it's going to be up the top here. If it's, say, 80% clay, then it'll be on this line here. 70%, 60%, 50%. So in here, we're looking at between 30 and 40% clay. We've also got sort of an even balance between silt and sand.
So if I brought in a cube.
So soil texture, here, when we do the ribboning, what we're looking for, we're squeezing the soil in our hand. We'll be doing this here. What we're trying to find is how much of a ribbon, how long can we make the soil stick together? If the soil doesn't really stick together and falls apart quite quickly, it'll generally be because there's a lot of sand. But if we can get a really long, up to 75 millimetre, 7.5, 3 inches in the old money, ribbon there of clay, there'll be a lot of clay in that soil, and clay sticks together well. So this is the process that we'll be using, and thinking about how it feels. Does it feel silky? Does it feel gritty? To work out where our soil is on this texture triangle. And that will tell us what the particle sizes are in the soil and give us some clues about management. Soil texture, as I was explaining before, also affects infiltration. So you can see here with the sand, I was describing them as lots of big beach balls, lots of large gaps in between there. So the water is going to flow through quite readily. Silt, medium-sized particles, some flowing through, some overflowing. Lots of clay. Often if you've got a compacted clay without much porosity, no holes in that soil made by animals or dead plant roots or microbes, then you'll have trouble getting your water to infiltrate into the soil and get into the soil profile. There's actually something missing on this diagram because it's a very simple diagram, and I was just explaining before, soil is very complex. When you have a lot of organic matter in your soil, then that will affect the way that the water and air flows through the soil. So more organic matter in the sand, water is going to infiltrate slightly more slowly, but it's also going to stick to the soil a lot more readily because lots more surface areas. Did you have a comment, question?
A lot of organic matter means you'll slide your sand.
What might happen if your soil is water repellent is it might be because there's a lot of oils or waxes in the soil. Now you might find that soil underneath a gum tree, an established gum tree, is a bit hydrophobic, afraid of water or water repellent because of all the oils that have come out of the gum trees. But generally, what the organic matter, which is something that was alive or something that's been eaten by something that was alive, this is how nutrients are cycled in the environment. Microbes and animals eat things, especially things with a lot of nitrogen in them. They want to eat them, and then they go through that organism's metabolic process and they come out the other end. And then other things eat those. So those organic matters, they complex, they make this surface more rough, and they provide more areas for water to stick to. When we have a situation where the infiltration is poor, we can't get water into the soil, or we've otherwise damaged the landscape, what will happen, we've removed too many plants, is that when we have rain, the water running off the land huge peak of water running off the land because it won't sink in, and then it will fall down. So you can see this chart here. If you can imagine that this chart, this line represents, say, the height of a river or a stream or a small watercourse. What we'd really want in our landscapes is for the watercourse to peak slowly so we don't have so much of a flood, and for the water to remain in the landscape for a lot longer. That's a much more functional landscape. The water systems are working much more effectively. Water is staying in the landscape. The landscape is buffering water. Here, in this situation, if you can imagine in an urban environment, we need lots of infrastructure to handle the water. We need big pipes to get rid of the water from the landscape quickly as possible because we've got too many paved surfaces, for example. So if you've got better soil structure, then you'll have better buffering of water and you'll have less, I'm sorry I've gone too far, you'll have less erosion. So this is obviously what's happening here. This is a photo just out of Braidwood, and lots of water is coming underneath the road here when the rain falls down and eroding these banks here. You can also see we've got livestock in the watercourse, and that's not helping the process. I'm sorry, I just remembered there were a couple more slides. I'm sorry about that. I'm so sorry. Just a few more moments sitting down. One thing that's important to remember is where in the landscape did we take our soil sample from? I've brought 3 samples along here. I've brought a topsoil and a subsoil sample from each place. So one of these is from my backyard in Braidwood. So you can see it's relatively flat here. This is a topographical map on Google Maps, and it's right next to a tiny little creek there. So that's what that looks like. You can see there's the topsoil and there's the subsoil. You can see quite clearly the change. You can also see I've taken a photo to show the extent of ground cover. I took this sample on Monday, the public holiday. So that's the Braidwood sample. And I've also taken 2 samples from a block of land in Reedsdale, and I've taken these 2 samples from different positions in the landscape. This is an ephemeral drainage line here, so only sometimes does water run down here, and you can see that it's actually different vegetation type because it's wetter. So I've got 1 sample from there and 1 sample from up on the ridge. So if people want to have a look at the difference between the samples depending on the position in the landscape, they can do that. We've got 3 tables out there, and I'm going to invite people who have taken their sample from whether it's from their backyard or their paddock somewhere. If it's from the top of the landscape on a ridge, can you please join this table over here? If it's from kind of mid-slope, I'm going to invite you to join the middle table, and if it's from a depression or lower in the slope, please join the bottom table, and we'll go out there and we'll set up the Emerson test. We'll get that in motion, and then we'll go and do some infiltration.